Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on August 13, 2025, just 3 days ago. The headline result is striking. With only hundreds of carefully curated examples, the method delivers state-of-the-art level reasoning. For instance, AIME 2024 at 81.87% and AIME 2025 at 77.29%. The paper is titled Beyond Scaling Law, a data-efficient distillation framework for reasoning, and the implications for model training are quite significant. In short, the framework optimizes teacher choice, compresses and filters data to preserve general skills, and enforces diverse reasoning trajectories to boost chain-of-thought learning. Building on that, the tweets claim the scaling law just broke. Far less data yields state-of-the-art reasoning, trained in hours, via data-efficient distillation, with moderate engagement. Alright. Here the twin scatter plots chart accuracy versus training corpus size, and they spotlight the supposed scaling law. Look at the red star near the low data region. Despite only hundreds of examples, the accuracy sits at the top on AIME 2024 and remains very strong on AIME 2025. Building on that, the other points drift upward only when data scales to tens of thousands, yet they still lag, which signals a Pareto frontier shift toward data efficiency. Okay, this diagram lays out the full three-stage pipeline. First, on the top left, several candidate large reasoning models each produce one chain of thought per question. Then a quick student distillation picks the best teacher. Moving down, the chosen teacher generates many trajectories per question, which then pass strict checks and an accuracy-based compression to drop easy items. Finally, on the right, the method selects the most different reasoning paths using Levenshtein distance, forming a compact yet diverse training set. Next, this table compares teacher-student pairs across 4 benchmarks, listing accuracy, average response length, and accuracy gain after distillation. Focus on the bold rows. The student distilled from QWQ32B consistently tops accuracy. For example, AIME 2024 at 79.58% and MATH 500 at 95.6%. Building on that, the delta accuracy columns show the largest boosts also come from QWQ32B. Reinforcing that the best downstream scorer is not always the best teacher. Now, this table lines up models against 3 math benchmarks, and it reinforces the earlier point about data-efficient distillation. Focus first on the bottom row. NTELER 132B Math posts 81.87 on AIME 2024, 77.29 on AIME 2025, and 95.2 on Math 500. Comparing across rows, many larger or heavily trained baselines trail these numbers, which highlights that a compact, curated corpus can outperform brute scale. Moving to this table, the key message is the careful compression and diversity beat sheer size. The baseline sits far lower, while the QWQ distilled student climbs to 79.58, then with right filtering reaches 80, and after hard selection plus diversity peaks at 81.87 on AIME 2024 and 77.29 on AIME 2025. Notably, Math 500 stays around 95.6, even when the sample count drops to just 237. Wrapping up, 2 takeaways stand out. First, smart teacher selection, plus strict corpus filtering, breaks the scaling law narrative, delivering top math and code scores with only hundreds of examples. Second, enforcing diverse reasoning trajectories, meaning varied chains of thought per problem, strengthens out-of-domain generalization. That is it for the AI Research Roundup. I am Alex. Thanks for listening.